Hello, dear students, and we are start our lecture number 8. The theme of our lecture, initial data for the design of technological machining process. Write down to your notes the theme of our lecture, initial data for the design of technological machining process, and the plan of our lecture. 8.1 Determination of optimal cutting data. 8.2 Setting the optimal cutting conditions for multi-tool machining. And 8.3 Process documentation. The technological process is designed on the basis of the working drawing of the part and the assembly drawing of the product or assembly unit. The technical specifications for the manufacture of the product and the drawing of the workpiece. The choice of the optimal process option for specific conditions, which provides the highest productivity and the lowest cost of processing, in some cases requires the calculation of economic efficiency and comparison of the efficiency of processing options. Such a choice largely depends on the volume of output, the production capabilities of the enterprise, the existing fleet of equipment, etc., design conditions, reconstruction of the enterprise using existing equipment, purchase of equipment, etc. The production program of the enterprise is determined by the annual number of manufactured products with a certain number of changes and a fixed shift duration. Based on the production program, a detailed release program is complete by Formula 8.1. In this formula, you can see the next parameters. P is the annual production program for this part. P suffix I is the annual production program of products. M is the number of these parts in the product. And N is the percentage of space parts for this part. Is the percentage of spare parts for this part. The production program and the labor intensity of products characterize the type of production and accordingly the specific requirements for the technological process of single, serial, and mass production. Please write down to your notes the formula 8.1 and all these parameters. The information basis for the development of technological process are technological classifier of the production object, classifier of technological processes, system for providing technological documents, standards of a unified system of technological documentation, typical technological processes and operations, standards and catalogs of technological equipment, standards of technological regimes, material and labor standards. Write down to your notes all these information bases for the development of technological processes. The need to develop standard technological processes is determined by economic feasibility and depends on the number of similar products found when grouping them according to design and technological features. To develop any single or standard technological process, for manufacturing a part, the design must be tested for manufacturability. The choice of tooling, technological equipment, tooling and means of mechanizations and automation is made taking into account the type of production, the nature of the intended technology, and the maximum use of available standard tooling and equipment. The main data on the equipment required for the technological process are taken from the passports of machine tools available at the enterprise, as well as from catalogs, reference data, and other sources. Data on the tool and fixture is determined according to current standards and catalogs and other reference materials. In a number of cases, it is also necessary to have data on the newly designed enterprises, specialized and special equipment, and a new type of tool designed by the tool industry. Such data can be obtained through descriptions of instructions or characteristics and diagrams outlining the technology for manufacturing typical parts on this equipment or using a special tool. This information makes it possible to identify the practical possibility of using this equipment and tools in specific conditions and is a certain incentive for the introduction of new progressive technological processes. And we start item 8.1, determination of optimal cutting data. Determination of optimal cutting data. The optimal cutting modes are set from the condition of ensuring the specific quality of the workpieces, surface roughness, machining accuracy, etc., and the economic feasibility of processing. When roughing, they are determined for reasons of obtaining maximum productivity, and when finishing, they are determined by the necessary machining accuracy and other quality indicators of the surface. Consider the definition of modes for single tool processing. The depth of cut during roughing is assigned from the condition of removing the allowance on one pass. That is, it will be equal to the intermediate allowance. If, according to the technical data of the machine, this is not possible, then the allowance is divided into several layers. It is desirable to take formula. You can see this formula on the slide. T is less or equal Z divided by 2 or 3. To reduce the number of moves, and Z in this formula, it's machining allowance. When finishing, the cutting depth is set taking into account of obtaining the surface of the required accuracy and roughness. In the case of performing roughing and finishing of the same name, in order to ensure maximum cutting performance per roughing stroke, it is necessary to design the removal of at least from 70 to 80% of the allowance. Feed during roughing should be technologically maximum allowable. It is limited only by the strength and rigidity of the TS technological system. When finishing, the feed must be provide the necessary quality indicators of the part. The cutting speed is calculated according to the formulas of the theory of cutting based on the conditions of economic stability of the cutting tool. We use the formula 8.2. V, it's cutting speed. It's equal A divided by T to the power of M. In this formula, A is a constant depend on processing conditions. T, resistance of the cutting tool. M is an indicator of stability. The economic durability of a tool is a reasonable time from the beginning of its operation to cooling. Please write down to your notes formula number 8.2 and parameters from this formula. And we are continuing the next slide. When tuning, the formula for cutting speed is formula number 8.3. In this formula, we can see the coefficients C suffix V, X, Y, K suffix V. All these coefficients depend on the material, the head treatment of the workpiece, the material of the cutting part of the tool, and other processing conditions. The spindle speed is determined by the formula 8.4. N spindle speed is equal 1000 multiplied by V and divided by PD. Small d is the workpiece diameter. And V is cutting speed. Write down to your notes formula 8.3 and 8.4. Similarly, the number of double moves of the table is found. The calculated values of the spindle speed, the number of double table moves, and the feet must be corrected according to the machine passport, choosing the nearest lower value. Linear cut-in speed after correction is determined by the formula 8.5. Linear cut-in speed after correction is determined by the formula 8.5. V cut-in speed is equal PDN suffix k divided by 1000. Then the effective cut-in power is calculated using the formula 8.6. Cut-in power n suffix y is equal p suffix z multiplied by v suffix k divided by 102 multiplied by 60. In this formula, p suffix z is the main component of the cut-in force, and it can be calculated using formula 8.7. So p suffix z is equal c suffix pz multiplied by t to the power x multiplied by s to the power y suffix pz. In this formula, c suffix pz, x suffix pz, and y suffix pz coefficients depending on processing conditions. The power of the machine spindle is found by the drive. N is equal n suffix d multiplied by nu. Nu is the efficiency of the machine drive on average from 0.8 to 0.85. N suffix d is the power of the electric motor of the machine. The cutting process is possible if n is less than n suffix d. Please write down to your notes formulas from 8.5 to 8.8. And if you haven't the questions about item 8.1, we start item 8.2, setting the optimal cutting conditions for multi-tool machining. When working on boring, longitudinal milling, multi-spindle drilling, and other machines, when processing is carried out with a set of tools fixed in one or more blocks, the tools may have different speeds. Cutting conditions are set according to the following method. Determine the depth of cut and feed for each of the tools. It's first method. For each block of tools, the minimum limiting feed is determined according to the standards. When roughing, it is limited by the rigidity and strength of the technological system. And when finishing, it is limited by the quality of the surface and the accuracy of the sustained dimensions. The minimum limiting feed is compared with the passport one and, if necessary, corrected. Calculate the cutting speed of each tool. Determine the limiting tool. This is the tool of this block, for which the minimum speed must be taken in single tool processing in the following order. For each of the tools, the cutting time coefficient is determined by the formula 8.9. Mu suffix t is equal small l divided by L suffix sigma. L is the cutting length of this tool. L suffix sigma, the total cutting length of the entire block of tools. Then the conditional economic stability of limiting instruments is determined by the formula 8.10. T suffix st is equal T block multiplied by mu suffix t. In this formula, T block is the stability of the tools of the block, of the setting, subject to their equal loads determined according to the normative tables. By resistance, T suffix st determines the cutting speed for each of the proposed limiting tools. The limiting tool is set according to the minimum speed. According to the cutting speed by the limiting tool, the spindle speed is found. Adjust the speed according to the passport of the machine. Make a verification calculation, for example, according to the power of the machine, and, if necessary, correct the calculated values of cutting speed, feed, and speed. And we start item 8.3, process documentation. The main technological documents are as follows. Road card. A description of the technological process of manufacturing or repairing a product, including control and movement for all operations of various types in a technological sequence, indicating the relevant data on equipment, tooling, materials. The content of operations is expressed without specifying transitions and processing modes. Road cards are used for production planning. Operational card, a description of the technological operation indicating the transitions, processing modes, and design norms. A set of operating cards is supplemented with a road card. Operating cards are used in series and mass production. Technological process card, a description of the technological process of manufacturing, repair, or coating of a product for all operations of a separate type of work performed in one workshop in a technological sequence indicating data on technological equipment. Sketch card. Sketches, diagrams, and tables necessary to perform a technological process, operation, or transition in the manufacture of repair of a product, including control and movement. Please write down to your notes all these cards. Road card, operational card, technological process card, sketch card. Next types of technological process documentation. It's technological instruction. Technological instruction. A description of specific methods of work when performing technological operations, including control operations, rules for the operation of technological equipment, a description of the physical and chemical phenomena that occur during individual operations of the technological process, Equipment list. A list of used fixtures and tools, cutting, measuring, and auxiliary, necessary to perform a given technological process or operation. The equipment list is the main document for calculating the tool economy of the plant. And bill of materials. Data of work pieces and consumptions rates of materials. Technological documentation, in addition to various cards and information, also includes drawings of initial blanks, drawings of fixtures, or interchangeable settings for them, drawings of special cutting, auxiliary, and measuring tools. Operational control charts are developed for technical control processes in which control tools and controlled sizes are given and summarily list of control operations is compiled. The composition and completeness of the technological documents necessary for the manufacture or repair of the product is determined by the list of technological documents. This sheet contains a list of all technological documents. Please write down to your notes 3 cards: technological instruction, equipment list, and bill of materials. So it was the last slide for today. Have your questions? If you have questions, please write your question in our Telegram group, and I try to answer. And for now, for today, we finished our lecture. Goodbye. See you next time on the next week. Goodbye and have a nice day.